Hello. Today, we will look at application problems that involve rational expressions. So, meaning that we'll have some word problems, but we're looking at specifically at rational expressions. Now, keep in mind that when we look at application problems, also known as word problems, okay, it is very important that you read the problems a few times. Okay. So the essential part of this is to make sure you read the problems a few times. Yeah. Because if you read it once, you may not quite understand or gather all the information that's there. Two, you should list the items that are known or write down. You should also list the items that are unknown. And then also, what is it? What are you trying to solve/find? Okay. So I think those are some important key points. I know in one of the previous application videos, I had given you like a blueprint list to follow, but these are mainly the key points. Please keep in mind that for application problems, when you're finished, the answer may have some sort of a unit. Yeah, so for example, if things are given in inches, you may have, and you're finding an answer that involves inches, you will have to write the answer as inches. So let's just dive into an example because we'll decipher the example. Okay, try to break it up into little pieces so you can understand. So here is the first example. So example one number is twice another number. So here we're speaking of two numbers, right? We're speaking of two numbers here. So one number, so let's call the number, this one number here, let's call it x. So let the number be x. I hope you followed what I recommended. Read the problem here a few times, right? Before you start writing things down. So I've basically skipped the first step because I did read the problems a few times. Okay. Now, one number is twice another. So if the first number is x, then the second number, so this is the first, the other number is 2 times x. Yeah, because one number is twice another. So if one of them is 2x, okay, if one of them is 2x, the other will be x. Okay. Now, the sum of their reciprocal, is 2. Now remember, is, okay, is implies equal, right? And we're talking about sum. So the sum of their reciprocal, meaning when I'm adding these two things, okay, that is going to be equal to 2. So the reciprocal of x is 1 over x, and the reciprocal of 2x and reciprocal of 2x is 1 over 2x, right? Reciprocal just means a 1 goes in the numerator, or you flip the fraction. So x will be x over 1. If you flip that, you get 1 over x. So the sum of the reciprocal, so 1 over x, the sum, we add 1 over 2x is 2. Okay, so that is equal to 2. So now we have to find our goal. Okay, this is find the numbers. So the goal is to first find x, then find the two numbers. So that's our goal. Okay, and it's very important that you remember what is the goal. Okay, so the goal is a two-part combination here. Okay, so we have a rational equation. Our rational equation here, the rational equation is 1 over x plus 1 over 2x equals 2, which is like 2 over 1. Okay, so let's solve for x. Solve for x. So we have 1 over x plus 1 over 2x is equal to 2 over 1, or 2. The denominators are already in factored form. Okay, so we just look for the common denominator. And the lowest common denominator here, is, we'll start off with the first term, which is x. And then we look at the next term, which is 2 times x. But notice that the x's are repeated, right? So this becomes just 2x. So we now multiply each term by 2x. So 2x times 1 over x plus 2x times 1 over 2x, and that is equal to 2x times 2. Now, as always, I said the denominators must cancel, so notice that this x will cancel with that x, leaving you with 2 times 1, and that is 2. In this case, the 2x will cancel with the 2x, so it's a 1, so 1 times 1 is 1. And that's equal to in this case here, there's really nothing in the denominator, so 2x times 2x becomes 4x. Now we can solve our equation. 2x plus 1, that becomes 3x. 2 plus 1, there's no x there. 2 plus 1 is 3 is equal to 4x. And to leave x by itself, divide both sides by 4. So we have 3 over 4 is equal to x. So it just happens in this case that the answer is 3. Well, the x value, this is not the answer. This is not the answer. Note, this is not the answer. Okay? This is the value of x. Okay? So remember, our problem, our equation, the equation is 1 over x plus 1 over 2x is equal to 2. So we have the value of x. This is our value of x. So now we have to simplify. What is 1 over 3 over 4? So to find the first number, this is our first number. Okay. To find the first number, we will have to plug in the value of x. Okay. We still have to plug in our value of x. So our first number here is 3/4. Okay, we have the first number. Now the second number, this value here, okay, we have to find that. And to find that, we have 2 times 3 over 4, okay, which is really the same as 2 over 1 times 3 over 4. That's the same as this. And notice you can simplify by dividing top and bottom by 2. So this becomes 1 over 1 times 3 over 2. And now we have our number. 1 times 3 is 3. 1 times 2 is 2. And there we have now our two numbers. Okay. So the sum of these two numbers is 3 over 2. Is 2. Now let's see what the question asks us to find. The question said find the numbers. Okay. Not find the reciprocal, find the number. So the numbers are 3/4 and 3 over 2. And if you add those two numbers, you will see you can do a check. You can perform a check. If you add those two numbers, you will see the result is 2. So here is my final answer. So it's very common, okay, very common that when students or anyone solve the equation, they think they're finished. And that's not the case. Okay? You should always see, and that's why I like, what is your goal? Okay. The goal is to first find x, which we did, then find the two numbers. Okay. So it happens that x is one of the number here. And then to find the other number, we have to multiply 2 times x. So let's look at a second example. Okay. So here's my second example. The speed of a boat in still water is 20 miles per hour. So the speed of the boat in still water is 20 miles per hour. And still water, okay, still water just means that the water is not moving, okay? The water, there is no movement in the water. So the speed in still water is 20 miles per hour. Okay? And that's the speed of the boat. it takes the same amount of time for the boat to travel 3 miles downstream. So you're probably wondering, what is downstream? Yeah, and downstream means the water is traveling in the same direction. Yeah. So if you look at my diagram here, yeah, if you look at the diagram, if the current is traveling this way, meaning the water, because the water move depends on the tide, if the water is traveling that way and the boat is traveling in the same direction, okay, then you're going downstream. Okay? On the other hand, if the current is going this way, okay, and the boat is going in the opposite direction, okay, then that is upstream. So upstream is when they're going against each other, okay? Now, as it does to travel 2 miles upstream, so you'll notice that traveling against the current, okay, you move less of a distance, which makes sense. We walk around against wind and with the wind. So if the wind is blowing against you, you will notice that you have to like fight to walk or struggle to walk, okay? And you will travel less of a distance. So they said, find the speed of the current. Now, you will read this a few times, okay? Please make sure you read this a few times. So the first thing here that I would say is that the speed of the boat, if we go back, the speed of the boat, okay? So we can say that let X represent the speed of the current, not the boat. So let X represent the speed of the current. Meaning here that X will be the speed at which the water is traveling. Okay, that's our X. Okay. But the speed of the boat. So if we go back here, the speed of the boat is 20 miles per hour. The speed of the boat is 20 miles per hour. So then we have the speed of the boat in still water is 20 miles per hour. So we can write that down. The speed of the boat in still water is 20 miles per hour, right? mph, miles per hour. Now, the speed of the boat upstream. Now remember, if you're going upstream, yeah, it takes the same amount of time for the boat to travel 3 miles downstream, that's with the current, as it does 2 miles upstream. Now, if you are traveling, okay, if you're traveling upstream, it means that you are traveling against the current, okay? So that tells me that, because if you're traveling upstream, it means you're traveling this way, right? That's upstream. So you're going against the current. The speed of the current is X. And we know the speed of the boat is 20. Okay. So the next thing we want to write here is that the speed of the boat upstream, the speed of the boat upstream, okay, is the speed of the boat 20 minus some value x, or some speed, right? Because the current value is x. So if the current value is x, still water, the boat would have been 20, right? Which is what we established before. So since you're going against it, you have some sort of a resistance. And this is only because we're going upstream, okay, against the current. And if we're traveling with the current, the speed of the boat, I wrote boat twice here, of the boat downstream, okay, is 20 plus x, because now you're getting some sort of a help with the water. The water is pushing you. Okay. You also have the distance downstream and the distance upstream. The distance upstream we also have the distance downstream. Okay. So if you look at your problem, 3 miles downstream and 2 miles upstream. So for downstream, it is 3, and for upstream, it's 2. Okay. So generally, sometime when I get these types of problem, I think some sort of a little table will be helpful. So I draw a table. There's a few things we're talking about. We're talking about the distance, okay? We know the rate, and we're talking about upstream and downstream. So if I fill in those tables, those values there, okay, the distance upstream is 2. So I will take that 2 and I will write it in there. The distance downstream is 3. So I will take that 3 and I will write it here. Now the rate, right? The rate downstream is 20 plus x. So downstream, we have 20 plus x. That's my speed, my rate. Okay? And for upstream, we have 20 minus x. Okay, so that's 20 minus x. So those was the information given in the word problem. We just did a lot of writing to see how we got them. Now, there is I'm not sure if you're familiar, we want to find the time, right? And there is a relationship between time. There's a strong relationship between the time and the distance and the rate. Okay. So there is a formula that distance, which we call d, is equal to the rate, which we call r, times time. Okay. which we call t. So generally, we write d is equal to rt. Now, if you solve this equation for t, okay, you will have to divide both sides. So this is the formula for distance. And this is not only for this problem. Distance is always equal to the rate times your time. Yeah. So if you rearrange this form, you will notice that t is equal to d over r. And we can use this here. This is very useful for us. Okay? We can use this to fill in the table because we have the distance and we have r. Okay. So if we go back and look at our table, okay, we have the distance, we have our distance, and we have our rate. So for the first part of the table here, the time would be 2 over 20 minus x. That will be the time for upstream. And for downstream, it will be 2 over 20 plus x. So the table is complete. Now we can probably see our equation that we have, because the problem said, okay, find the speed of the current. So we're looking to find the speed of the current, which we know the speed of the current, we call it x. But how do we get two equations? Well, if we read the problem once more, the speed of a boat in still water is 20 miles per hour. It takes the same amount of time to travel 3 miles downstream. It takes the same amount of time to travel 3 miles downstream as to travel 3 miles upstream. So the time of these things here, the time are equal based on their distance. And that's our two equation. Our two equation, so the two equation, or the equation, is 2 over 20 minus x, because the time is the same, is equal to 3 over 20 plus x. And now we can solve. Okay. Now we can solve this. So here we want to solve for x. So solve for x. So we have 2 over 20 minus x, 3 over 20 plus x. Lowest common denominator, since there's nothing to factor in either denominators. Okay. So the lowest common denominator here, lowest common denominator, let's start out with the first one, which will be 20 minus x. Move down, second denominator is 20 plus x. And then we multiply each one of those fractions by the common denominator. So if I multiply the first one by 2 over 20 minus x, and that is equal to 3 over 20 plus x, but we'll multiply that by the common denominator, which is 20 minus x times 20 plus x. As always, I said that the denominators must cancel out. So the 20 minus x will cancel with the 20 minus x, leaving me with 20 plus x times 2. So we have 2 times 20 plus x. And that is equal to, notice on the right side, 20 plus x will cancel with 20 plus x, leaving with 3 times 20 minus x. Okay. If I now solve for x, 2 times 20, that becomes 40. 2 times x becomes plus 2x. and that is equal to 3 times 20 is 60, and 3 times x becomes minus 3x. Solving for x, I am gonna add 3x because I always move the smaller x first, and this becomes 40. 3x plus 2x becomes plus 5x, and that is equal to 60, and minus 3x plus 3x cancel. Now I'm going to minus 40 both sides, because I'm trying to isolate x. So what happens is the plus 40 and the minus 40 is 0. We usually say cancel. So we have 5x is equal to 20. And finally, to solve for x, we will divide both sides by 5. And if we divide both sides by 5, 5 divided by 5 is 1. So this becomes x is equal to 20 divided by 5 is 4. So x is equal to 4. But you're not finished. What is the question asking? The question says that we have to find, okay, find the speed of the current. We know that the speed of the current is x, but x represents the speed, the current. So the speed in this problem was miles per hour. Okay, so the speed here, the speed of the current, the speed of the current is 4 miles per hour. Okay, or if you want to write it out, spell the word miles, per hour. So that is our final answer. Okay. So if we look at another example, similar example, and this time I'm not gonna present that little diagram or box that I had started the problem with. Okay. So let's look at my next example. So here we have the current of a river is 3 miles per hour. Okay. So that's the current. So notice no drawing was given here. So it's sort of similar to the last problem. Just want to see if you can follow through without the diagram what's happening. But you can always draw your own little diagram, right? So the current of a river is 3 miles per hour. It takes a motor boat a total of 3 hours to travel 12 miles upstream. So that means the boat is going against the current, okay? And return 12 miles downstream. What is the speed of the boat in still water? Okay. So now we're asking for the speed of the boat in still water. So the first thing I'm going to do, there's two things actually. We can draw a little sketch here if we have a little river. So let's say that's my stream, and I have 2 boats. So let's say one boat is somewhere here. Okay. And let's say we have another boat somewhere over here. I think that's how a boat is drawn. We can put a little sail on it, whatever. But it has engines, so it can't be a sailboat. And the current, the water is moving this way, right? This is our current. So the current of a river is 3 miles per hour. So we know that this is 3 miles per hour. Okay. So what we can do is let x equals the speed of the boat in still water. So what we will do is let x represent the speed of the boat in still water. Okay. Then if we do that, we can have, and we know that time is distance over the rate or the speed, right? We know that distance, the little formula b is equal to r times t. So if we draw our little table as we did before, if we create a little table, similar table, we're talking of about a few things here. Yeah. We're talking about the distance, we're talking about the rate, and then we can figure out the time. And once again, we're talking about upstream, and we're talking about downstream. Yeah. So what distance, if you look at the problem, the distance they travel, the distance travel is 12 miles upstream and 12 miles downstream, okay? So our distance here is 12. Now, remember, if you're going with the current, you add, and if you're going against the current, you subtract. So if I'm going upstream, okay, I have to subtract. And if I'm going downstream, I have to add. So if the speed of the boat, if the speed of the x represents the speed of the boat, okay, so therefore my rate, the rate upstream would be x, because it's the speed of the boat, minus the current of the water, okay? Because if I'm going upstream, upstream will be here, and here will be downstream. Downstream because these two things are the same. That's why. So your boat will move faster downstream. So for upstream, we subtract, and then for downstream, the rate downstream will be x plus 3. Okay, so we can fill that in our table, x minus 3 and x plus 3. And if we have this now, if we have this, we can find the time, because time is the distance over the rate. Okay, you have to recall that time is equal to d over t, d over r. So here, the time for upstream will be 12 divided by x minus 3. And for downstream, it will be 12 over x plus 3. So I have my table complete. Now I can solve these two. Well, the total time for the trip and back is 3 hours. The total time for the trip and back is 3 hours, right? It takes the motorboat 3 hours to travel upstream and 12 miles downstream. So 12 miles upstream and downstream. So if we go back now, we're looking at the total time. This time plus this time is equal to 3. So if we write that, our rational equation is 12 over x minus 3 plus 12 over x plus 3, and that is equal to 3 hours. Okay, the upstream time and the downstream time. So now we have our equation we can solve for x. So solve for x. So we have 12 over x minus 3 plus 12 over x plus 3 is equal to 3. There is nothing in the denominators to factor, and keep in mind 3 is the same as 3 over 1. Yeah. So my lowest common denominator here will be x minus 3 times x plus 3. And now I multiply that by each term of the rational expression. So x minus 3, x plus 3 times 12 over x minus 3 plus x minus 3 times x plus 3. I'm going to multiply that by 12 over x plus 3. And I multiply the 3 also by the lowest common denominator, which is x minus 3 times x plus 3. So as always, I said that the denominators will cancel. So this x minus 3 will cancel with that x minus 3, leaving you with 12 times x plus 3. So we have here 12 times x plus 3 plus, as always, the denominator will cancel. X plus 3 cancel with x plus 3. So we have 12 times x minus 3. And over here, we just multiply these out, right? Because 3 over 1 is 3 over 1. So it doesn't matter. So we multiply this times this times this, right? Everything has to be multiplied. So that gives me 3 times x minus 3 times x plus 3. If we multiply this out, okay, 12 times x becomes 12x. 12 times 3 is 36. Positive 12 times x becomes positive 12x. Positive 12 times minus 3 becomes negative 36. And that is equal to, if you multiply the parentheses first, since it's difference of squares, it becomes x squared minus 9. Okay, if you FOIL out those two parentheses, you will get x squared plus 3x minus 3x minus 9. And then the plus 3x and the minus 3x will cancel out. And now if you distribute the 3, okay, so we have 12x plus 36 plus 12x minus 36 is equal to 3x squared minus 27. If we combine like terms, you will notice that the plus 36 and the minus 36 cancels. And then 12x plus 12x becomes 24x. So we have 24x is equal to 3x squared minus 27. Now notice that this is quadratic. So to solve this, we have to let it equal to 0. And to do this, if we move this to that side, we get 3x squared minus 24x minus 27 is equal to 0. Yeah. We can divide throughout. We have a GCF of 3. So this tells me that 3 times x squared minus 8x minus 9 is equal to 0. And if we factor the inside here, we have x minus 9 times x plus 1. So now we have the factor. We solve here, we have 3 factors. So 3 is equal to 0, or x minus 9 is equal to 0, or x plus 1 is equal to 0. Now, obviously, 3 cannot be equal to 0, right? So this is no good. 3 cannot be equal to 0. If you solve here, you will add 9 to both sides. So we have x is equal to 9. If you solve here, you will subtract 1 on both sides. So we have x. This will cancel out here. It will cancel out, equals to -1. But don't forget, you're not finished. Remember, what is x? X, you said, represent the speed of the boat in still water. Okay? So the speed of the boat is where the rate at which it's traveling. So the speed of the boat, okay, cannot be negative. Okay? The speed of the boat cannot be negative. So we throw out this answer because the speed is not negative. Okay? Obviously, if the speed was negative, the water would be pushing the boat backwards. So x here, the speed of the boat, is 9 miles per hour. Okay? The speed of the boat in still water is 9 miles per hour. And this here is the answer. So it will take some time for you to get a hang of this, right? Especially because it's word problems. I don't think you will have a problem solving for x, but getting the two equation takes some time, right? Let's look at a different scenario, because we use this one, or we go visit the pool every so often. But how long does it take for that pool to fill or that pool to empty? Because every so often they drain the pool also. Okay. So my next example will talk about filling of a pool. So if we look at this example here, an inlet pipe fill a pool in 10 hours, while the drain pipe, so here's our inlet pipe, right? That's the one that fill inlet. And the drain pipe empty in 12 hours. So here is the drain pipe. Okay. If the pool is empty and both the inlet and drain pipe are open, how long will it take to fill the pool? Okay. So if we open both pipes where the pool is filling and it's draining at the same time, how long will it take to fill the pool? So let's see. So it will be helpful in terms of how much work is done by each pipe in 1 hour, right? So that could be a help. How much work is done by each pipe, by the filling side and by the empty side in 1 hour. So let X represent the time it takes to fill the pool with both pipes. So we'll start off with let X represent or equal, okay, the time it takes to fill the pool with both pipes open. So if you notice in my examples, then I always let X represents what I want to find, right? That's exactly what the question is asking. If the pool is empty and both the inlet and the drain pipes are open, how long? So that's the X. Okay. Now, if the inlet pipe can be filled in 10 hours, so here is my inlet, okay, and here is my out. So if the inlet pipe can fill the pool in 10 hours, then in 1 hour, it is 1 over 10. So this is 10 hours to fill. In 1 hour, it'll be 1 over 10. And if it takes 12 hours to empty in 1 hour, in 1 hour here, it'll be 1 over 12. So now that we have this, we can actually set up an equation. Yeah? We can say that the amount of time, the amount filled, so the amount filled by the inlet pipe minus the amount filled by the drain pipe, that is equal to the fraction of pool filled, right? This is equal to the fraction of pool filled with both pipes open. The difference of the two is what's going to happen here. Now, we don't know this here. This is an unknown, right? That's just X we said. So because X represents X here, X represents the time it takes the pool to fill with both pipe open. So our equation, our rational equation, we have is 1 over 10 minus 1 over 12, and that is equal to 1 over x. And this is the equation we have to solve. So we will solve 1 over 10 minus 1 over 12 is equal to 1 over x. Okay? So what is my lowest common denominator? The lowest common denominator between 10 and 12 is 60. We have x, so the lowest common denominator is 60x. If we multiply every single term by 60x, okay, we have 60x times 1 over 10 minus 60x times 1 over 12 equals to 1 over x times the 60x. As usual, the denominators will cancel, as we say. So the 60 divided by 10 is 6. So 6 times x times 1. This becomes 6x. As usual, the 12 and the 60 would cancel to be a 5. So 5 times x times 1, and that just becomes minus 5x. And here, the x will cancel with the x, and that leaves me with 60. So like terms, 5x and 6x, so 6x minus 5x is x is equal to 60. Now, what does x? You're not finished, right? It's very common that when we get here, we think we're finished. You're not finished. So if you look, what comment did you make? You said let x represents the time. X represents the time. So in this problem, we were talking about hours, okay? 10 hours, 12 hours. So if the pool is emptied and both the inlet and drain pipe are open, how long does it take to fill the pool? So that means if this pipe was left open, okay, and you're pumping water in, it will take the pool 12 hours, okay? Sorry, it will take the pool 60 hours. 60 hours, that's what we had, right? X is equal to 60. So it will take the pool with both pipes open. It will take the pool 60 hours to fill. And the answer is 60 hours. Okay. So as always, we can see that there is a whole bunch of different ways and different applications for rational expression. We could also look at planes flying. We can look at this Ferris wheel problem. We can look at the ski, the lift for this, taking the skiers up to go come down the hill. So there are many different problems for application. So as always, I always say, please try to practice as many problems as possible. Until then, I'll see you in the next video.